Here are solutions for quiz 1 for Math 251. Basic idea here, we're given a function and that function tells you position. It specifically tells you the height of a ball. Okay. Anytime your function tells you position, when you're asked for average speed, really what that translates to is you want to find the slope of the secant line. And the nice thing about a secant line is we can calculate its slope exactly at this point in the class. Can't calculate the slope of the tangent line exactly at this point in the class, but later on we'll be able to. But slope of the secant line, that's something that is accessible. It's something we can do. In fact, we have a formula for it. It's kind of just our slope formula. You can think about it as the average rate of change formula if you want. And the basic idea is just the change in the y-coordinates over the change in the x-coordinates. Okay, if I'm going to figure this out, it looks like there's 4 things I need to plug into this formula. I'm given 2 of them. Told x1 is 2 and x2 is 2. Did I say that? x1 is 1 and x2 is 2. I need to know y2 and y1. Then I'd have everything I need. Well, it turns out that if you know x1, you can figure out y1. It's just the y-coordinate that corresponds with the x-coordinate of 1. It's the output when the input is 1. In other words, it's f of 1. Take your original function here, and everywhere you see an x, instead put in a 1. I grabbed a calculator over here, but I think for this one, you could probably just do it in your head. 1 squared is 1 times negative 2 is negative 2. Negative 2 plus 26 is 24, I believe. So we get y1 is 24. And y2, same basic idea. It's what comes out when you put 2 in. Well, I change all the x's into 2's. I'd get this thing. Negative 8 plus 46 sounds like 38. If I did that math right in my head. Now I have the 2 y-coordinates. I plug those in. I got 38 minus 24 divided by 2 minus 1. Looks like, what, 14 over 1? In other words, 14. That's the speed of the ball, the average speed of the ball over this time period. Height in seconds. It doesn't tell me the units. Don't worry about units, I guess is what I'm getting at. Let's call it 14. 14 something per something. Good enough? If you could do that, you can do the next one because it's the exact same thing. The only thing that changes is instead of plugging in 1 and 2, you plug in 1 and 1.01. So I already know that y1 is 24 from above. y2 will be whatever negative 2 times 1.01 squared plus 20 times 1.01 plus 6 is equal to, which, I don't know, maybe you could do it in your head if you're really trying to show off, but I am not. So I'm just going to do it over here. 1.01 squared is equal to this, times negative 2 is equal to this, plus, I actually don't need these parentheses here, but I'm going to put in extra ones just to really emphasize things. I want to take that answer and I want to add something to it. 20 times 1.01. That's what I got here. Gives me this. So that's your answer? No, because you didn't take care of this 6 yet. Fine. That plus 6 gives me this number, 24 point something, 1598. Now I know everything I need. M is equal to y2, 24.1598, minus y1, 24, divided by x2 minus x1. Looks like it's 0.1598 divided by 0.01, or if you multiply the top and the bottom of this fraction by 100, you get 15.98. The average speed from time 1 to 1.01 is 15.98. Okay, so what? Well, what I'm really interested in is the instantaneous speed. Turns out this is a very interesting question. What's the instantaneous speed? Something we're going to devote this entire class to. But right now we don't have a great way of figuring it out. We don't have a way of calculating the instantaneous speed. But we do know that the instantaneous speed at time 1 will be damn close to the average speed from time 1 to 1.01 because these two numbers are so close together. The answer here will be something close to 15.98. I guess 16. That's my guess. Number very close to 15.98, 16. Looks like a decimal point. I meant that as a period. I'll just leave it like this. I guess 16. That's my answer. Call that good enough. It's a very unsatisfying way of coming up with the instantaneous speed. We'll spend a lot more time on this later. But for now, that's all we can do. All right. Question 2. Now, instead of being told the function, we're just given a graph of the function. You might be able to guess what this is a function of. It looks like a parabola shifted left and down. You could probably come up with the equation of this thing, but that's not the point. The point here is I'm going to sketch the secant line. So if I want to, basically what I'm going for here is, do you understand what it means? Like, yeah, you can calculate average speeds up here. You can calculate the slope of the secant line. That's great. But do you know what it means? Like graphically, geometrically? If so, do it. Okay, the secant line from x1 equals -4. Here's where x equals -4. It looks like we're talking about this point right here. To x2 equals -1. They gave me 2 points, which they would have to do if I'm going to draw a secant line. I got this guy right here. That's my best attempt at drawing a straight line. Call it good enough. There's my secant line. Calculated slope? Sure, I can do that. I've been calculating the slopes of secant lines this entire problem. It's y2, the y value corresponding with when x equals -1. Looks like it's 6. Minus y1. It's the height here. It looks like -9 to me, and I guess this was actually -6 is this height. Minus -9 divided by x2, -1 minus x1, -4. -6 minus -9 is the same as -6 plus 9, which is 3. -1 minus -4 is the same as -1 plus 4. Turns out that's also 3. Slope of this line is 1. Yeah, that seems reasonable. It looks like every time I go up 1, I go over 1. Cool. Calculate the slope of the secant line. What about I keep saying the tangent line is the one that's really important. Here it says sketch the tangent line. Maybe I'll underline that in green so that later on people see my answers and they know what I'm talking about. When x1 equals -4. Well, let's see, here's -4. That's this point right here. So now I've already drawn the secant line that goes through this point. Now I want the tangent line at this point. Try my best to draw a straight line that just barely hits at that point. Something like that. It's not really a straight line, but we can pretend. That's a straight line that's tangent right here. Visually estimated slope, about -1. You call it -2, yeah, that's fine. If you call it about -1 or -2, how about that? Just don't call it 0 or 10 or something, and you're fine. About -1 or -2. Seems like a weird answer, but it did say estimate, so that's my answer. And so ends the most uninteresting quiz of the entire quarter.